Anyone who has spent a day on a metal roof knows the specific sound of a high RPM nightmare. You lean into the drill, the bit slips, and instead of piercing the sheet, the screw violently wobbles, chewing up the surface and throwing off sparks without actually biting into the steel. To avoid that slipping, crews fall back on an incredibly tedious routine. They walk the entire grid of the roof, marking and manually pre-drilling thousands of individual pilot holes before a single fastener is driven. That extra step effectively doubles the labor hours on a job. It also introduces thousands of tiny opportunities for misalignment, where the pre-drilled hole in the panel doesn't quite match the purlin beneath it. But the immediate labor cost isn't the biggest threat. If a cheap fastener doesn't seat perfectly, it leaves a microscopic gap. Water finds that gap. Within a season, water ingress brings accelerated rust and quiet structural damage. Getting a roof secured means fighting against friction, weather, and time. Solving that equation requires a fastener engineered specifically to eliminate every one of those failure points. That is exactly what the STX Self-Drilling Screw is built to do. It is a precision-engineered, single-step component designed to completely remove the need for pre-drilling. This diagram breaks down the process. The C1022 steel case-hardened point acts like a high-speed drill bit, tapping structural steel without slipping. Above, the textured drill shield expands the hole, protecting the upper thread coating as it drives. This schematic illustrates the upper section for flush applications. The underside of the countersunk head features specific anti-spin ribs. These ribs ream a precise recess into the material, allowing the head to sit completely flush with the surface. By combining high-speed initial penetration with aggressive thread-holding power, crews can drive a secure fastening point in a fraction of the time. The result is a massive reduction in labor hours and significantly faster project turnarounds. The moment a screw pierces a steel panel, it creates a vulnerability. That tiny entry hole is now the weakest point on the roof, and it has to be immediately sealed against the elements. Looking back at this technical breakdown, the top section shows how STX addresses this. Tucked beneath the hex head is an EPDM sealing washer. This material actively resists UV degradation and maintains elasticity across massive temperature swings. During installation, as the screw is driven into the crest of the roofing sheet, that washer physically compresses, pushing tightly against the steel to create a dynamic, watertight barrier that forcefully repels wind-driven rain and standing water. A permanent seal requires material that survives decades of thermal cycling, absorbing the constant expansion and contraction of the metal without cracking. Beyond physical water pressure, fasteners in industrial and marine environments face invisible threats. Galvanic corrosion, acid rain, and highly alkaline atmospheres will rapidly dissolve standard metallic coatings. This document outlines the Rustburt coating chemical defense system. It uses 3 layers: metallic zinc, a chemical conversion film, and a baked ceramic top coating. A cross-linking chemical reaction physically bonds these layers together, forming a dense, rigid, anti-corrosion barrier. Relying on a single material leaves the steel vulnerable. By layering a ceramic shield over a chemical conversion film, the screw gains a comprehensive, multi-layered resistance to the most aggressive industrial pollutants. Designing a highly capable fastener in a laboratory is one thing. Maintaining that exact molecular structure and threading tolerance across millions of units requires precise mass manufacturing. These environmental characteristic charts document the results of that precision. STX screws are tested and graded against extreme conditions, ranging from mild urban areas up to ISO Category 4 and 5, certifying their lifespan in severe marine and heavy industrial zones. Achieving that standard allows these fasteners, proudly manufactured in India, to supply highly demanding structural and commercial applications around the globe. Structural integrity depends on the absolute replication of these microtolerances across millions of units, ensuring every screw in a bulk order performs exactly like the engineered blueprint. For the roofer standing 3 stories up with a drill in hand, all of this chemistry and engineering translates to one simple reality: a completely frictionless, one-step installation. The bit bites instantly. The threads engage without slipping. And as you can see here, the case-hardened point carves out clean, tight curls of steel, seating the head perfectly flush against the surface. By engineering out the common bottlenecks, the slipping bits, the manual pre-drilling, the stripped heads, crews gain speed, high tensile strength, and a permanent, weather-tight hold. The structural integrity of a massive commercial facility ultimately comes down to its smallest components. Choosing the right fastening point is the definitive foundation of building with confidence.